Hi everyone, we are going to be looking at probability more today, like we have in the last couple days, and looking specifically at the simple probabilities and its complement. So first thing we need to understand is that a probability is the likelihood of an event happening and is expressed as a value ranging from 0 to 1. So anything between 0 and 1 can be a probability. Anything that's bigger than 1 is impossible because 0 could be written as 0%, but 1 whole, if we're talking about the whole thing, that's 100%. And you can't have more than 100% challenge or 100% probability of something happening. So it's always going to be between 0 and 1. And if we put that onto a number line, it might be easier to see and to think about. So 0 is the same as 0%, 1 is the same as 100%, and a half is 50%. And then obviously we can have things in between those. And you'll often hear words like unlikely, equally likely, impossible, certain, and likely. So when we are looking at a 0% chance of something happening, that would be something that is impossible. So go ahead and label 0% or 0, a probability of 0 is something that's impossible. And a probability of 1 out of these options is something that is certain. A probability of 1 means it's absolutely definitely going to happen, 100% chance. Now 50%, that's directly in the middle, that is equally likely. That means it's completely even chance that it could happen or couldn't happen. Anything between 0 and 50% is unlikely. And we could label one of these numbers. If you notice all these dashes, if it's 0 and 50, that means this would be 0.1, 0.2, 0.3, 0.4 would be the probability as a decimal. Or for instance, 0.3 was the same as 30%. Because remember, you're going to move the decimal point 2 places to turn a decimal into a percent. Same thing over here, if that's 50, 60, 70. Here's 0.8, and what is 0.8 as a percentage? You should remember, you might have to add a 0. It's not 8%, it's 80%. So let's go ahead and look at some examples and use the language to identify if it's impossible, unlikely, equally likely, we still need to say likely, and certain. So if you jump into a pool, getting wet if you jump into a pool, well, that is certain. I always have students that say, if you jump into a pool, the expectation is you're going to get wet. 2, burning your dinner if you cook it too long. Out of these 5 choices, which one do you think is the best description if you burn your dinner for too long? Well, I would say it's likely. Just because it goes too long doesn't necessarily mean it's going to be burnt. It could be dry. It could be, if you're making soup for dinner and you cook it too long, it's not going to burn necessarily, but it is likely that a lot of times it will. Next, water boiling at 75 degrees. So, in the classroom right now, it's 75 degrees. If I have a cup of water, it's not going to start boiling on me. That is impossible. What do you think? Getting a ticket if you are speeding. Which one of these descriptors would work for that? Well, I would say it's probably likely. A lot of people can get away with it, but we do know that if you're speeding, there's a good chance that you will get a ticket. Number 5 says scoring 2 points on a safety in a football game. If you're not familiar with football, when somebody gets sacked in their own end zone, the other team gets 2 points. This is something that does happen, but it doesn't happen very often. It's unlikely. And then last, a coin landing on heads when it's flipped. Which one of those things would make sense? Well, that would be equally likely. So now that we have talked about probability being between 0 and 1, we talked about taking a decimal and moving the decimal point 2 places to make a percent. We've talked about descriptors of what that means in real life. Let's look at some actual numbers. So Steve is going to randomly select jelly bean from a bag, use the information from the table to complete the sentences below. So this is the number of jelly beans in all these different flavors. One of the flavors is toothpaste, which sounds kind of gross, but Steve is half as likely to select a blank than a blank jelly bean. So which one of these would be half of something else? Well, I noticed that 24 and 12. So since toothpaste is half of that, Steve is half as likely to select toothpaste than a lemon. These must be some Harry Potter beans. Next, Steve is 2/3 as likely to select a blank jelly bean than a blank. Okay, so we need a fraction that's going to be equal to 2/3. What two numbers would I compare to get a fraction of 2/3? Look at these different numbers and figure out which would make sense. Well, with a little bit of work, we could see that 12 is 2 groups of 6 and 18 is 3 groups of 6. 12 and 18 can both be divided by 6 and it equal 2/3. So that means Steve is 2/3 as likely to select toothpaste than blue raspberry. Next, Steve is 75% as likely to select what two things? So we need two numbers that would be equal to 75%. As a fraction, 75% is 3/4. So what two numbers could I make into a fraction that would have that relationship, 75%? Well, if I use that same groups of 6, blue raspberry is 3 groups of 6, lemon is 4 times 6, so 18 over 24 can be simplified to 3/4, meaning that we have blue raspberry and lemon. All right, we are going to skip this question right now, and we're just going to move on to the next thing. So turn page, and let's look at some actual definitions. Number 1, simple probability is a ratio. Go ahead and underline ratio because we want to always start by creating a fraction or a ratio. In the numerator, it's the successful outcomes. This is what we're looking for, compared to the total number of outcomes. And we always know that in math classes, we try to find abbreviations and short ways of writing things. So instead of saying, what's the probability of something happening, like event A, instead of saying the probability of an event named A, we would just say P of A. And this means that we're going to take all the ways that A can happen, put that number in the numerator, and we're going to figure out the total number of outcomes. And we could find the total number of outcomes by making our sample space, like we did previously. And then that would be the fraction that's the simple probability. And if we wanted to, we can turn it into some kind of a percent. So the simple probability is if it was successfully happening. Complement is the opposite of that. So that's the probability that the event does not happen. And what we need to know is that the probability that the event does happen and the complement that it does not happen, when you add those two percentages or those two fractions together, you should get a sum of 1 whole. So the probability, and again, there's a shortcut way of writing it. This is the probability if A is not going to happen. That little apostrophe means that it's not A. And we're always going to put what we're looking for on top and the total outcomes on bottom. So what does that all mean? Simple probability complement. These are the way it does happen. These are the way it doesn't happen. Let's look at some examples and it might make some more sense. So we have probability of choosing a marble with stripes. What's the complement of choosing a marble with stripes? So first of all, how many marbles have stripes? Well, the probability of stripes is 2 out of 6.
Pardon this interruption. Carter Fitzpatrick, if you're in the building, please report to the main office. Carter Fitzpatrick, if you're in the building, please report to the main office. Thank you.
So this is the probability that it is stripes. There's 2 of them out of 6 of them. So it doesn't ask us this specifically, but what if I said the probability that it's not stripes? If 2 of them are stripes, then the ones that are not stripes are 4 out of 6. You can't really see the sparkles in the copies very well, but these are the ones that have sparkles. And if 2 of them do have it, then 4 of them don't, because there's a total of 6. So, what is the probability that it's not sparkles? Well, if 4 of them have sparkles, then 2 of them don't have sparkles, so that's 2 out of 6 don't have sparkles. Let's try it again. Probability of finding one with a heart. So how many have hearts? We have 2 with hearts. That's the numerator. That's what we're looking for. The denominator is the total number of outcomes. So we have 1, 2, 3, 4, 5, 6, 7 things that could happen. So the probability that we get a heart is 2 out of 7 choices. The next one asks for the probability that it's not a diamond. So first of all, we have to count how many of them are not diamonds. We have 1, 2, 3 that are not diamonds. And remember, the little apostrophe means not, or the complement. And then the denominator is the same, the total number of things that could happen. And again, if I said 3 of them are not diamonds, so how many are diamonds? You would say 4 out of 7, because 3 out of 7 and 4 out of 7 makes the total 7 out of 7, or 1 whole. Okay, standard of rolling a number cube. A standard number cube is being rolled, so just one of them. Don't worry about that second number cube. What's the probability of rolling a 6? Well, on a standard cube, we have 1 out of 6. On a standard number cube, we have 6 sides. 1, 2, 3, 4, 5, 6. How many of them are odd numbers? That would be odd, odd, odd. 3 out of 6. Half of them are odd, and half of them are even. Try the next 3 on your own and see how you do. What's the probability of getting a black sock? Again, you need to have the total in the denominator and the number that show up on top. Same thing for white socks. Okay, when you're doing these, black would be 10 out of 24, and you could simplify that to 5 out of 12. But I would take either of those answers. White socks says the remaining were white. Well, there's a total of 24. 6 of them are navy, 10 are black, so that means between the navy and the black, there's 16. If we take away those 16 out of the total, we're going to be left with 8 more socks. And since the remaining were right, that's 8 out of 24, or 1/3 if you simplified. The spinner below, not a 6. So how many are not 6? All of them, except for that one. So 1, 2, 3, 4, 5, 6 out of 7 are not a 6. How many are a 3 or a 4? So 3 or 4. There's 2 of them that fall into that category. 2 of them are 3s and 4s out of 7. And then odd numbers, we have 1, 2, 3, 4 out of 7. Next we have the letters in the word soccer. Soccer has 1, 2, 3, 4, 5, 6. And we're picking one at random. So how many vowels are there? A, E, I, O, U. We have 2 vowels out of 6, which is the same as 1/3. If it's not a vowel, it's a consonant. That means we have 1, 2, 3, 4 consonants out of 6, 2/3. And how many times does the letter C show up? 2 out of 6, or 1/3. What's the probability of selecting a nonfiction book off the shelf at the library? Oh, the probability is 1/3. Describe what 2/3 represents. So if 1/3 of them are nonfiction, then you know that 2/3 of them are what? Well, 2/3 would have to be the opposite. It would have to be 2/3 are fiction. Because remember, 1/3 and 2/3, there would be, this is the ones that are, and these are the ones that are not, and they have to add up to one whole. All right, go ahead and try these. Remember that the apostrophe means that how many of them are not a 7. Remember the odds and evens. Try the rest of these on your own and see how you do.